In industrial applications, there is one type of condition that can eat through an alloy diaphragm within just a few months. When facing this challenge, almost everyone starts with the same solution, including us. The first time, we got it wrong too. This is the story of how we admitted that mistake and how we truly solved the problem.
This customer is a leading lithium hexafluorophosphate company in China. Lithium hexafluorophosphate is a key raw material in lithium battery manufacturing. Among all the industrial applications we have experienced, their working conditions are among the most extreme. And because the conditions are so harsh, their requirements for instrumentation are extremely demanding. Their medium is highly corrosive hydrochloric acid combined with high temperatures. Under these conditions, pressure transmitters with gold-plated diaphragms could only survive for 3 to 4 months. Once the diaphragm was corroded and penetrated, the measurement data was lost. Even imported instruments costing more than 10,000 RMB per unit faced the same problem. Replacement was still needed every 3 to 4 months. With hundreds of measurement points across one production line, even a single failure could interrupt operations. Replacing instruments had become part of their daily routine. When we first entered this project, our approach was also replacement. We used our own gold-plated diaphragm pressure transmitters to replace the imported ones. Lower cost us, that was true. But after installation, the result was exactly the same. Corrosion occurred, failure happened within 3 to 4 months. That was the moment we truly realized. The problem was never the brand, and it was never the price. The problem was the solution itself.
Gold plating was never the right choice for hydrochloric acid, hydrofluoric acid, and high temperature conditions. Corrosion was only a matter of time. Resistance to strong acids is never just about changing one material. It is a complete graded system. We classify wetted materials into 5 corrosion resistance levels, starting from 304 and 316L, moving up to 316L with PTFE, titanium alloy, and Hastelloy C-276, with the highest protection level achieved through tantalum diaphragms and full PTFE ceramic solutions. The harsher the operating conditions, the higher the protection level required. For this application, level 4 was required. Gold plating was not just one level behind, it was far from enough. So we stopped trying to fix the old approach and took a completely different path. The diaphragm was upgraded to Hastelloy C-276 with a PFA coating on the surface, providing strong resistance against corrosion and preventing deformation even under negative pressure. The sensing core was replaced with single crystal silicon technology, achieving an accuracy of plus or minus 0.075%. Between the diaphragm and the flange, we added a 60 mm heatsink to keep high temperatures away from the sensor. This solution is not unique to us, but applying the right technology precisely to this specific application, while delivering a solution that is both reliable and cost-effective, that is where our advantage lies.
After installation, we waited together with the customer for 3 months. 3 months later, we removed the transmitter for inspection. The diaphragm showed no signs of corrosion, not a single trace. The moment the customer saw the result, the decision was made. Replace all units across the production line.
Large-scale delivery is never about luck. It comes from every quality check before the product leaves the factory. Every diaphragm must pass salt spray testing, immersion testing, and real-world simulation tests under acidic and alkaline conditions. Every transmitter must go through helium leak detection, high and low temperature cycling tests, vibration testing, as well as overload and range fatigue tests. Only after a final 48-hour power on aging test is it approved for shipment. With this production line, we can deliver 30,000 units per year with a lead time of just 5 working days per unit. The original transmitters lasted only 3 to 4 months. Today, our solution has been running stably for at least 1 year. The cost per unit has been reduced from over 10,000 RMB to around 2,000 RMB. For this single application alone, the customer saves nearly 1 million RMB every year. And today, just at this subsidiary's production lines, 150 pressure transmitters are already our products.
3 months after installation, the customer took the initiative to share their feedback with us. Their equipment manager said one sentence that I have always remembered. Customer, quote, "This is a great thing. You should share this solution with more of our subsidiaries." That sentence later became our roadmap. From this one subsidiary, we are now moving into their headquarters and other affiliated companies. One sentence, one production line partnership, one group-wide partnership.
For years, some of the most demanding applications in China's lithium battery materials and electronic chemicals industries have relied on imported instrumentation. A transmitter costing over 10,000 RMB and requiring replacement every few months represents a hidden cost across the entire industrial chain. We don't claim to have any secret technology that no one else can achieve. What we truly solve is not just an instrument issue. It is the challenge of matching the right solution to the right application and helping production lines run reliably over the long term. from micropressure to high pressure with 4 measurement ranges, from 304 stainless steel to full PTFE and ceramic solutions with 5 levels of corrosion protection, covering 4 major application categories: clean, moderately corrosive, highly corrosive, and hygienic media. This is Feejoy's pressure transmitter portfolio. And this is the confidence that empowers us to take on the next complex operating condition.